Children, in this video, we are going to learn about characteristics of organic compounds. Before going to learn characteristics of organic compound, we are going to learn what is meant by organic compound. So, mainly organic chemistry is the study of compounds of carbon. Compounds of carbon. So carbon has a tendency to form more compounds with itself and with other atoms, maybe hydrogen. Carbon can form compounds with hydrogen, oxygen, nitrogen, sulfur, halogens, etc. So, the tendency of an atom to form chain of bonds with the atoms of same element is called catenation. What is catenation means? Tendency of an atom to form chain of bonds like this. This way also can go, this way also it can go, this way also it can go. That property is called as catenation. So the word organic is derived from living organisms. So organic compounds were thought to be found only in living things. That is, a cell, the basic unit of living thing, consumes, creates and consists of mainly organic compounds. For example, DNA, the genetic material, lipids that forms our cell membrane, and the glycogen, the energy reserves stored in our liver, are all organic compounds, except a few inorganic compounds like salt, water. All others such as food, medicine, cloth, cosmetics, fuel, etc. These are all compounds of carbon only. Except a few, most of the things what we are used in our daily life is made up of carbon only. So, for example, so first it was a belief that organic compounds are all derived from the living things. But later, a scientist called Berthelot, he defeated this idea because he prepared acetic acid. In the lab, Berthelot prepared acetic acid. By Berthelot, he confirmed that organic compounds can also be prepared through laboratory. Since then, millions of organic compounds were synthesized and characterized. So the field of organic chemistry is very vast and its principles find applications in many industries, maybe due to food, textile, petrochemical, pharmaceutical, dye, polymers, fertilizers, cosmetics, such as it's a mighty ocean like applications are found organic chemistry. So the knowledge of chemical bonding, molecular structure will help the understanding of the properties of organic compounds. We know that carbon atomic number 6, so configuration is 1s2, 2s2, 2p2, 2s2, 2p2. So second shell having 4 electrons. To attain the stable electronic configuration, it needs 4 more electrons. But it is difficult to lose 4 electrons and getting plus, and even gaining 4 electrons getting minus. It's very difficult. gaining 4 electrons and losing 4 electrons to attain the nearest noble gas configuration. So this implies that carbon cannot form ionic bond. It cannot form ionic bond because it cannot even able to transfer 4 electrons. So they can form covalent bonds. They can only form covalent bonds. So the formation of 4 covalent bonds. So carbon can form only covalent bond. So during the excited state, one electron from the 2s orbital shifted to the 2p orbitals. So formation of 4 sigma bonds by carbon. So carbon can form sp3 hybridization as well as sp2 hybridization as well as sp hybridization. sp3 means it forms a tetrahedral shape. sp2 means it can form a trigonal planar shape. sp means it can form a linear geometry. So carbon can form sp3, sp2, sp. 3 hybridization it can go through. So now what are the characteristics of organic compounds? So first point, this you have to learn. They are covalent compounds. That I will write and teach you. First point. First point, characteristics of covalent compound number 1. They are organic compound. Characteristics of organic compound number 1. They are covalent compounds. Compounds of carbon. This is the first point. Covalent compounds of carbon. Second point, they are insoluble in water. Third point, soluble in organic solvent like benzene, toluene, ether, chloroform, etc. Fourth point, most of the organic compounds are inflammable except CCl4, carbon tetrachloride. Then they possess low boiling point and melting point due to covalent in nature. Organic compounds can be characterized by a functional group. What is meant by a functional group? Functional group is an atom or a combination of bonded atoms. ஒரு ஆட்டமாக இருக்கலாம் அல்லது ஒரு group of atoms இருக்கலாம். React in a characteristic way of the inorganic molecule in which it is present. Then next, they exhibit isomerism. This is a unique phenomenon, isomerism. Then the last one is homologous series. What is meant by homologous series? That is, in organic compound, there are many groups. For example, alkane. Alkane means compound containing single bond. Alkene means compound containing double bond. Alkynes, compound containing triple bond. So general formula for alkane is CnH2n plus 2. Alkene CnH2n. Alkynes CnH2n minus 2. So these family differ by a CH2 group. For example, here if you see, if n is equal to 1, what is the formula? C1 H2 2 into 1 plus 2 upon CH4. When n is equal to 2, C2 2 2s are 4, 4 plus 2 6, C2 H6. When n is equal to 3, C3 2 3s are 6, 6 plus 2 8, H8. So see, the difference between these two is CH2. Similarly, CnH2n, when n is equal to 1, CH2 When n is equal to 2, C2H4. When n is equal to 3, C3H6. See the difference? Carbon CH2. Difference is 2. Likewise. So they differ by a CH2 group. Successive members, a series of organic compounds, each containing a characteristic functional group, and the successive members differ from each other by a CH2 group, that is called a homologous series. So these are the main characteristics of organic compound. They show regular gradation in physical properties, but almost they have similar chemical properties. So these are the main characteristics of the organic compounds.